Alright guys, in this video we'll be looking at some vocabulary words that we'll need to be familiar with. The first one is the origin. Now you recall from the Cartesian coordinate plane video that this axis is called the x-axis, this vertical line is called the y-axis, and where these two axes meet up, right here, is called the origin. So this point is the origin, and the ordered pair for that origin is 0, 0. So origin simply refers to the intersections of the x and y axis. And again, that ordered pair is 0, 0. The next term we have is ordered pair. Ordered pair simply refers to a point located on the Cartesian coordinate plane. So if I put a point here, that point is an ordered pair. And when we write an ordered pair, we describe the x first and then the y. So in this particular case, the x value on this point or ordered pair would be 4. The y value on that ordered pair is 5. So this is the ordered pair 4, 5. Next term we have is something called a relation. And a relation is a set of points or a set of ordered pairs. Now, a set of points or a set of ordered pairs can be described a couple of different ways. One way is to show points or ordered pairs on a Cartesian coordinate plane. So these points would be an example of a relation. However, a second way that we can show a relation or a set of ordered pairs is by actually writing those ordered pairs, such as 1, 2, 3, 4, 5, 6. So this would also be a relation. All it is a set of ordered pairs. Another option would be using something called a mapping. And a mapping is simply a set of numbers. We've got a set of numbers over here in our x, and a set of numbers over here for y. And we have some arrows pointing in the direction that the x and the y go together. So in this case, 1 points to 5, which gives us the ordered pair 1, 5. 2 points to 4, which gives us the ordered pair 2, 4. 3 points to 6, therefore we have the ordered pair 3, 6. So this would be another example of a relation. It's simply a set of ordered pairs. And a fourth way that we could describe a relation or a set of ordered pairs is using an equation such as y equals 2x. So this would be another example of a relation. So again, a relation is a set of points or a set of ordered pairs. Alright, next term we have is called a function. A function is a relation in which each x value occurs once. Now you recall that we said a relation is a set of points or a set of ordered pairs. So a function is a special type of ordered pairs in which the x value only occurs once. So x's cannot be repeated. So I've got a couple examples down at the bottom here. If you look at example number 1, what we're doing is we're looking at the x's. I'm looking at this x here, this x here, this x here. Notice how none of those x's repeat. Therefore, we can call this set of ordered pairs a function. So this one is a function. However, if you look at number 2 there, number 2, if we look at the x values, we've got a 5, a 3, and a 5. Notice how this 5 is being repeated. And because that 5 is being repeated, we cannot call this set of ordered pairs a function. So this one is not a function. If we take a look at number 3, again, look at the x's. You got a 1, you got a 3, and you got a 5. Notice how none of those x's are being repeated. Therefore, we can call this set of ordered pairs a function. If you look at number 4, we have a 3, a 4, and a 3. Notice how these 3's here are being repeated. And because that 3 is repeated, this set of ordered pairs is not a function. Now remember we said we could also describe a relation as a set of points on the Cartesian coordinate plane, which is what I have over here. So if you look at number 5, we have 3 points or 3 ordered pairs on this graph. The first ordered pair that I have over here is -5, +5. The ordered pair I have here is 2, 3. And the last ordered pair I have is 6, -2. So if you look at those x values, we're going to check to see if any of those x values are being repeated. I've got a negative 5, I've got a positive 2, and a positive 6. None of those x values are repeated, therefore we can call this a function. So again, as long as no x's are repeated, we can call the set of ordered pairs a function. Okay, the next two terms we're going to look at are the words domain and range. Domain refers to the set of x coordinates. So if you look at the relation or the set of ordered pairs that I've provided, 2, 3, 4, 5, 6, 7, and 5, 1, the domain for this set of ordered pairs would be all of the x coordinates. So we got a 2, you got a 4, you got a 6, and you got a 5. So the domain would be the values 2, 4, 6, and 5. So again, it's simply the x coordinates in each of our ordered pairs. Now if you look at range, range is just the opposite. It's the y coordinates in the set of ordered pairs. So if you look at the points or the ordered pairs that I've provided, this time it's 3. That's a y value. We also got 1. We got 6. And we also have 4. So the range for this relation or the set of ordered pairs would be 3, 1, 6, and 4. Again, it's simply the y coordinates in each of our ordered pairs. Next term we have is the word discrete, and discrete refers to individual points or points that are not connected. As you can see, I've given you an example here. I've got 4 points, and notice how these 4 points are not connected. They're individual. So we call this discrete. So anytime we have individual points or points that are not connected, we call that discrete. Next term we have is continuous. Continuous is just the opposite of discrete. Now we're talking about points that are connected, usually making a line or a smooth curve. Alright, so continuous means that we have a line or a smooth curve. Points that are connected. Next term we have is increasing. Increasing is when the x and y values increase. As you'll notice here, the points or our coordinates, as each x value increases, the y value is also getting larger, larger, and larger. When we say increase, we say that the points or the graph is increasing from left to right. Notice how this graph increases. It's going up from left to right. Our last term is decreasing. Decreasing is just the opposite of increasing. Here, as the x values increase, the y values are going to decrease. So as the x values get bigger, the y values get smaller. And then when we read the graph, you'll notice here the points are decreasing. When we read the graph from left to right, the graph decreases. So again, decreasing is when the x values increase, the y values decrease.